Imagine a complex system moving in a perfectly synchronized rhythm, handling every task without a single human intervention. It manages the daily basics, reading records from an Excel table, fetching the right documents from SharePoint, and emailing them via Outlook. But then, a massive marketing campaign launches. Suddenly, the volume of data entering the system doesn't just increase, it surges. The once smooth process begins to crawl. What used to take minutes now stretches into hours, creating a massive backlog that the system can't clear. It is easy to assume that once the manual work is gone and the software is running, the job is finished. A system that handles routine work can still break when the load increases. To fix the delay, we have to look at the specific logic driving the automation. This diagram maps out the architecture of the flow. We can trace the path from the initial manual trigger through the 3 levels of SharePoint document retrieval. The specific point of friction lives right here, in this orange step, labeled Apply to Each. This animation shows how the default logic works. The system processes records one at a time, finishing the first task completely before it even looks at the next one in the queue. The software is executing the task, but it is still thinking linearly, mimicking the way a human worker tackles a pile of paperwork. Applying that linear human logic to an automated system creates a speed limit that will always fail when the volume scales up. To remove that limit, we use a configuration called concurrency control. This setting changes the architecture to parallel processing. Instead of one gate, the system opens 5 lanes, allowing multiple records to process at the exact same time. The backlog clears immediately because the system is now doing the work of 5 linear flows at once. Fixing a major bottleneck like this changes how you look at the rest of the system. You start to see other, smaller inefficiencies. This sidebar lists several advanced tactics, starting with filtering and cleaning your data before it ever enters the main loop. You can further improve performance by reducing unnecessary calls to your source systems and replacing repetitive individual tasks with bulk operations. Real optimization happens when the focus shifts from simply completing a task to making the entire system as efficient as possible. This isn't just about one software sitting. It is a broader philosophy for building systems that can handle growth. The bottom of this infographic outlines a 3-stage framework for managing growth. Stage 1, automate, is the foundation to eliminate manual work. Stage 2, optimize, is the diagnostic phase to hunt down bottlenecks. And Stage 3, scale, prepares the system to distribute massive workloads. The author's notes at the bottom of this page confirm that the most important work often begins after a process is up and running. The most resilient systems result from looking for efficiencies long after the initial setup is complete.